There are several types of equation solutions and types of equations based on the solution that you get. The ones that we'll consider in Chapter 1 are those identity equations, an equation that's true for all real numbers, a conditional equation, an equation that's true for at least one real number, and then inconsistent equations, equations that are not true for any real numbers. We would say that they have no solution. Here's an example of an identity equation, one that's true for all real numbers. Feel free to pause your video and write any information that you need to down. It is 2 times the quantity x plus 3 equals 2x plus 6. We know from experience that we would need to remove the grouping symbol either by division or by using the distributive property. For this technique, I think the distributive property is helpful. If we remove the grouping symbol, we would be 2 times x would be 2x, and 2 times 3 is 6. And you can see that the value we have on the left is identical to the value that we have on the right. That is an identity. They are exactly the same equation. If you don't notice that and you are still using your equation solving algorithm skills, you might know that you needed to group your linear terms and your constants together. To move a linear term, I would have to subtract 2x from both sides. Those would cancel, and then I would have the statement 6 is equal to 6, which is still true. This is an identity. It is true for all numbers. You always get a true statement, and the left side is identical to the right. To say this in mathematical terms, we would say that this is true from negative infinity to positive infinity. X could be any value at all real numbers. You probably can hear my cat snoring in the background. I apologize. He's having a hard day. So there was one of those that was an identity equation. Now let's look at one of these. That is a conditional equation. Most of the ones that we work in elementary algebra problems are conditional. In other words, this equation only works under the condition that x is equal to a specific value. Here's an example of one of those, and I think you know that you could solve this by subtracting 4, which would give you 3x equals 6, and dividing by 2, which would give you x equals 2. This is a conditional equation. It's true under the condition that x is equal to 2. To work it out, it would look like this. 3x plus 4 equals 10. To work that problem, you subtract 4 from both sides, group your constants together. Use your inverse operation of division to divide out your 3's. X has a value of 2. This is conditional. This equation only works under the condition that x is equal to 2. 2 is the only number that would solve the equation. And then there are inconsistent equations. Inconsistent is an equation that is not true for any real number, or equations that have no solutions are considered inconsistent. Take yourself a moment to pause or jot down anything that you'd like to write down with this. I'll do the same out to the right, and then we'll zoom in. Inconsistent. So using our same method to distribute, that would be 2x plus 6 is equal to 2x plus 2. If you compare the left side and the right side, you can see that these are not identical, which means this is not an identity. You would need to explore further. To solve an equation like this, where you have linear terms on both sides and constants on both sides, you must group the linear with the linear and the constants with the constants. To move the constants together, you'd use that inverse operation of subtracting 2x. Those would cancel, and you would have left 6 is equal to 2. That is not true. When you get a false statement, it means that you have no solution. This is an inconsistent equation. There is no real value of x that solves the equation. Okay, here's one for you to try. You can pause this video, work through the problem, and then once you know a value for x, if it exists, determine did you have an identity, a conditional equation, or an inconsistent equation. The first step you might notice would be to remove those grouping symbols. So let me demonstrate that information here. I copy the problem down. I'll work on removing the grouping symbols. Notice that there are two terms on the left of the equals, but over here I have several. It needs to be balanced, so this side I need to simplify. 4x minus 7 is equal to 4 times x, that's 4x. 4 times minus 1, that's minus 1, and then plus 3. It's still out of balance. There are 2 terms here and 3 terms here. I have terms that I can combine together. They are like terms, so that this is written in the proper format. 4x minus 1 plus 3. Negative 1 and 3 makes a total of positive 2. And if you stopped at this point to examine your equation, you would notice that 4x minus 7 is not identical to 4x plus 2. So we know it's not an identity. We keep working. Make a note, not identical. Keep solving. If it's not identical and you need to keep solving, then you're at the point where you are grouping linear terms with linear terms and constant terms with constant terms. The linear terms are 4x. To move a 4x, use the opposite operation. Those would cancel, and you're left with negative 7 equals positive 2. Negative 7 is not equal to positive 2, therefore you have no solution, because this was a false statement. And this makes this equation be inconsistent. How'd you do? There are also problems in 1.2 where you'll be comparing graphs and reading the percentages based on the categories. I think you've had a good bit of explanation with those, and I won't add them to the video. But you can send me an email if there's something you don't understand with a screenshot. Hope this has helped.